Okay, let's get into it. We're going underground for this deep dive. Literally, we're looking at the unsung heroes of, well, infrastructure security.
Right.
Specifically, we're focusing on the NTI E-UCLD-600. That's the undercarpet leak detector. Our mission here is to really understand the problem this thing solves.
And it's a fascinating problem. I mean, this technology exists for one simple reason. Water is the silent killer of enterprise assets.
Silent killer. I like that.
Totally. We're talking about data centers, network closets, archives, places where a small leak under the floor could go completely unseen for weeks.
Until it's way too late.
Exactly. So this thing's core job is just sensing water or any conductive fluid where you can't see it under the carpet.
Yeah.
It's all about proactive defense.
I'm looking at the dimensions here, and that's the part that's just, it's kind of blowing my mind. It's 1.75 inches wide, but only 0.06 inches high.
Yeah.
That's thinner than a penny. I mean, how does something that thin even work? How is it not just crushed immediately?
Well, that minuscule height is the whole design breakthrough. You know, it has to be that thin so you can hide it and so it's not a trip hazard.
Right, of course.
But the real insight here isn't just its size, it's that it's an area sensor.
Okay, what does that mean? Like a net?
Sort of. Instead of a spot sensor that just protects one little point, this is a long cable.
Yeah.
You lay it out across a huge area so you get this continuous linear detection.
So you don't have to guess where the leak might start.
You don't have to guess at all. The cable covers the entire path. And obviously all the electronics inside are 100% waterproof. That's a must.
That makes a lot of sense. If you have a massive server room, you just run this thing all over the place. So how does it scale up?
That's where the engineering for these big facilities comes in. The model we're talking about, the E-UCLD-600, that's 600 feet of cable.
That's a lot.
It is, but they make them as short as 10 feet and all the way up to the E-UCLD-1000 model, which is 1,000 feet of continuous protection.
Wow.
Yeah, they use a special 2-wire plenum cable for that.
Okay, hold on. Plenum. For those of us who aren't in construction, what does that mean and why is it important here?
It's a fire safety thing. The plenum is the space used for air circulation, like under floors or above ceilings.
Well, you'd install this.
Exactly. So a plenum cable is low smoke and low flame. If there's a fire, it won't fill the building with toxic smoke. It's a critical safety requirement.
Got it. And I see it has RoHS approval too.
Right, which means no hazardous materials. Important if something is going to be sitting under your carpet for, a decade.
Okay, so the cable is just the sensor. It feels the water. But how does it yell for help?
It can't. It's just the eye, right? It needs a brain. This detector has to connect to an NTI X system. Does operate alone.
So why not just build an alarm into the cable itself? Why add another whole system?
Because in a place like a data center, a simple beep just isn't enough. The X is the central intelligence. It handles all the complex alerting. Sending emails, text messages, SNMP traps to the network guys. It makes sure the right person gets the right alert instantly.
So the cable is the trigger, but the UX is what actually saves the day.
You got it.
And it's basically cheap insurance when you think about it. I saw the 600-foot version is about $280. That's, what, a fraction of the cost of one server? It's nothing.
It's a rounding error.
And I assume you can hook that up to something like a really loud local alarm, too.
Oh, absolutely. They have things like the EBP-1600 piezo alarm. Screams at 103 decibels to tell the technician on site, hey, the problem is right here, right now.
So at the end of the day, what this whole thing is providing is just awareness of a hidden risk.
Exactly. It turns an unpredictable hidden disaster into a predictable, manageable alert. It's about preemptive maintenance, not crisis response.
Here's something to think about then. You have these massive multi-million-dollar data centers or priceless historical archives, and their ultimate protection from a hidden water leak. It relies on a piece of technology thinner than your fingernail, just lying there silently under the floor. It's this tiny, dedicated sensor that's protecting our largest, most valuable assets from a seemingly small threat. That paradox of scale is it's just fascinating to me.